There we go. Okay. So to help us better organize the business analytics of an organization, a framework is created where we look at the data that's coming in to be either structured, it's very well formatted, very structured, like in a table where you have rows and columns and you have data and you have fields. It's just very nicely organized. To semi-structured, maybe like a Word document. There's a structure to it, means there are paragraphs. The paragraphs have sentences. The sentences have punctuation marks, right? Semi-structured. To unstructured data, that's all over. Nothing is in the same pattern, but it's your company data. Or the data that was collected over the period of time, and there's no pattern to it. There's no pattern to the data. This could be voice notes, meeting notes, videos that were collected during meetings or events. I mean, it could be some kind of version control documentation that was done internal before the product went external. It could be anything that is totally unstructured. And now, as an organization, you have to figure out, okay, where do we place this? And here in this nice framework, it tells you that we have an operational control on all three of them, management control, strategic planning, and information system support. So that's what this framework talks about. The nature of decisions that are mainly made are either operational control oriented, management control oriented, or strategic planning oriented. These categories are displayed right here in this matrix. The decision matrix, the three primary classes of problem structure, and three broad categories of nature decisions can be combined in a decision support matrix that consists of 9 cells. Lower level managers usually perform the tasks in cells 1, 2, and 4. So 1, 2, and 4. This is lower level managers. Okay, structured. They're dealing with structured information. The tasks in cell 5 are usually the responsibility of middle managers and professional staff, which is management control of semi-structured stuff, right? And 6, 8, and 9 are generally carried out by the senior executive. Six, 8, 9. So the business analytic process, which we have been talking about, is based on the insights generated from historical data, as we talked about. The use of business intelligence or analytics in organization varies considerably. In smaller organization, the business analytics may be limited to using an Excel spreadsheet. In larger organizations, they may be using a sophisticated high-end tool like Microsoft Analytics or Oracle Analytics or IBM analytic tools. The development of one or a few related analytic applications to the development of infrastructure to support enterprise analytics. I mean, you have a wide variety within the industry. However, the target is to solve the enterprise-wide problems and also to solve the local departmental problems. But these tools are expensive. The people to maintain them are expensive. Not every organization can maintain it. But the organizations that lock themselves into the department level probably are creating what we call a data silo. And we need to break the data silo, because if the data silo is created, then the information is not getting exchanged, shared, and It's there, but nobody knows it's there except for the department. And depending on if that data is at the knowledge level or not, if people start leaving the department, all the data is getting lost. Nobody knows where what is because things are not streamlined. So all of these things are important. Now, the business analytics process starts on page 382. The entire business analytic process begins with a business problem, often called pain points by practicing managers. When organizations face business problems, they often turn to business analytics through the process that's illustrated in figure 12.3, which is this guy, okay? So the business problem comes in. You have a data management where the data comes in from all external sources, from all different kinds of places, and then it makes its way into the data warehouse. Through there, it goes through the descriptive analytics, where we look at what has happened. Then it goes through the predictive analytics, where we look at what could happen. And then we look at the prescriptive analytics, where what should we do? Okay, so those are the three different things. Now, for example, if you look at the auto industry, in the auto industry, you see that X number of cars were sold last year. As a company, how many new cars should I create this year? Should I make this year? So what has happened last year? What could happen this year? And then also, if country goes in recession, or if the interest rates become too high, people will not spend as much money as they would typically do with the rising car prices. And then dealership is asking on top of that the market adjustment price. Interest rates are higher, so people won't be able to afford the car that they could easily afford in normal days. As a result, people will not buy my cars. So should I really be producing as many cars as I did last year or even the year before? Or if I'm coming with a brand new model, that means I have a lot of R&D cost added to it. How will I going to distribute that over the course of next 4 years or 5 years, however long I want this model to last, provided I will not be able to sell many this year because of the market conditions? Yeah, I mean, like as a business, I got to be looking at all of this stuff. And then I have a supply chain problem. If I am not buying enough, my supplier will stop making stuff for me. Why would they wait for me? They have employees to feed too, right? They will look elsewhere. That's exactly what happened during pandemic. A lot of these guys were making products for cars. We bought less cars. The whole world bought less cars. And those companies that were providing chips to the car companies, they then turned their doors, they opened their doors to consumer electronics. And they went in that market because people were consuming a lot of electronics to an extent that something as simple as webcam was not available in the market. If you're looking for a good quality webcam, there was like a wait list. So those kind of things, companies need to figure out ahead of time, what will I do? How will I survive in long run, in long term? So descriptive analytics, predictive analytics, and prescriptive analytics, that's exactly what these tools are, okay? Then comes the presentation tool. The presentation tool are all three types of analytic produce results, right? And then the presentation tool will help you put these results forth. Now, these results can be presented in a variety of ways. You could either present it in the form of a dashboard, which is like a software application, which nicely lays things out for management, and they can easily see, okay, this is the data in the graphical form, and you click on it, it zooms in, zooms out. You can cut a piece out and zoom into that piece only. You can do all sorts of stuff. Or it could be a simple tool like slide deck from Google or PowerPoint or something like that, okay? So anyway, business analytic tools. A wide variety of tools are available to analyze data. This includes Excel as well. And sometimes you would install software on top of Excel or plugins on top of Excel to add extra capabilities to Excel, which is not there, built in by default. Then you have multi-dimensional analysis, which is also called OLAP, online analytical processing. So what you're looking at is you're looking at a data not in just rows and columns. You're looking at the data in depth as well. For example, I want to look at the sales of all 4 of my location in all 4 quarters in last 5 years. You know, I've added so many dimensions to the data set. So I should be able to look at any item in any quarter, in any year, in any location. Okay. So that's what basically multidimensional analysis does. Descriptive analytics was briefly talked about. So organizations must analyze huge amounts of raw data to make sense of them. This overall process is basically what we call data reduction. So you throw away the data that you don't need, or you convert the raw data into more useful information so that you're dealing with less information to look at. And we talked about reports, I think a few chapters up. And then we talked about, we have drill down reports, we have exceptional reports, we have summary reports. All of those reports, actually, some of them allow you to condense the data in one place. For example, I want to see how much total revenue we made in Thanksgiving in the state of Wisconsin. And I want this breakout by state, not by counties, by state. Okay. So things of that nature. Online analytical processing, also referred to as multidimensional analysis, so OLAP involves slicing and dicing information because you want to drill down into the process. That's what basically it does. Data mining is another way of you trying to learn your data. You're looking for patterns in your data. For example, how many people that shop with us have a household income between 50 and 100,000 and are between the ages of 30 and 40. And then you use that data and then you try to figure out, okay, why is their spending habit different from the spending habit of people in their 20s to the spending habit of people in their 40s to 50s to 60s and so on and so forth. Or how is the shopping habit by gender? Or how is the shopping habit by other criterias, like the people who rent versus the people who own the houses? And the people who own the houses, do they also own their automobiles? And people who don't own their automobiles, are they leasing it, or are they have they basically are doing a mix? Some are leased and some are on payment plans, or all of them are on payment plans. Lots of stuff to consider. Decision support systems, which basically combine models and data to analyze the semi-structured problems that we talked about, and some unstructured problems. So it just analyzes, and those are difficult to analyze because there is no structure to it. You have to code for it to be able to read it in a structured fashion and be able to make some sense out of it. So when we were going through training with Intel, I think that was last year, and one of the scientists that works for Intel happened to be the author of the book that he was teaching us from. And he explained to us some of those algorithms that they may use in these kind of systems that would go behind the scene and start reading stuff. And then, of course, you know, as a scientist, he mathematically solved those problems. And then on those mathematical algorithms, computer algorithms were written. And then those computer algorithms were packaged in the form of applications or sub-packages, which programmers can use to solve day-to-day problems. I mean, I remember when I was going through my master's program, we actually had to do similar kind of stuff where we would take mathematical algorithms for audio or video compressions, and we will convert them into computer algorithms. And then we will convert those algorithms into code and write an application that if you throw an audio or a video into that, it will compress it. So anyway, I mean, just to give you an idea what kind of stuff could go behind the scene into this. But anyway, here's an example of Blue Nile, which is an online retailer of certified diamonds. The firm's website has built-in decision support system to help customers find the diamond that best meets their needs. Blue Nile's DSS provides an excellent example of sensitivity analysis, which is what-if analysis and goal-seeking analysis, all of these different kinds of analysis. So the Blue Nile website, when you go there and you click on diamonds in the upper left corner, on the drop-down box, you will see search for diamonds. Keep in mind that when you experiment with the Blue Nile DSS, the number of round diamonds available will vary from what we obtained when we discussed the DSS and performed the analysis. So the reason is that the Blue Nile's website is updated in near real time as the company sells its diamonds. So that's basically why you will see constant change in data. And then there are many types of diamonds, but for this example, if you click on round, and you will see all sorts of stuff. When the author ran it, he probably ran through this was his experience when he ran through that. Sensitivity analysis examines how sensitive an output is to any change in an input while keeping other inputs constants. So, for example, here he started working with slide bars for the carat variable, and slight change here or there could, of course, affect a lot of things on the other hand. And then he ran the what-if analysis and goal-seeking analysis. Goal-seeking analysis, for example, let's look at it like this, that you set yourself a goal, and now you work backwards. What will I do to meet this goal? So it will go into its inventory system, and we'll start picking up material and the diamonds and the cuts and the ring and the gold and blah, 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 and the making cost and all of that stuff to figure out different rings that you can purchase on your goal. So that's what basically those analysis would help customers make better decisions. Moving on to predictive analysis, which examines, as we learned before in that diagram, if you remember, that was a few pages up. Was it here? Yeah, here it is. Okay, which is figure 12.3. Predictive analysis. What could happen? What could happen? So let's go to predictive analysis. So BA tools in predictive analysis. Organizations use a wide variety of business analytics tools and statistics procedures in performing predictive analysis. And the tools include data mining, as we talked about before, but now from a different perspective, not in terms of historical, okay? So the statistical procedures include different kinds of regressions, linear, multiple, logistic regression. And here, the data mining, which can perform two basic operations, identifying previously unknown patterns and predicting trends and behaviors. The first operation is a descriptive analytics application, and the second is predictive analytics operation. So identifying previously known patterns, that's what was done in the previous step, and predicting the trends and behaviors would then be done through the data mining in this one. So the likelihood of people who fall under XYZ criteria, for example, those who own a house in the range of $300,000 to $500,000 and their cars are all paid off, and the total household income is between $150,000 to $200,000, and everybody is employed, XYZ, whatever parameters you want to set over there, considering all of that, what are these people tend to behave, or what is trending with them, kind of stuff. Moving on to descriptive analytics. So in this example, the correlation between daily, oh, hold on a second. What is the, oh, I don't know why it's throwing so many examples here. Just one second. Oh, perspective analytics. Okay. Goes beyond descriptive and prescriptive. And it models by recommending what should you do after you have collected the historical data and after you have analyzed it. What should you do? What are the possible outcomes that you can work on? And that's basically what prescriptive analytics does. Organizations use a wide variety of tools and statistical procedures to perform prescriptive analytics, and some statistical procedures include optimization, simulations, and others. For example, some corporations do work on simulations a lot. And sometimes those simulations don't have to be like gaming simulations. Those simulations are, they create hypothetical scenarios. And then in those hypothetical scenarios, they say, okay, how will we survive in this situation, in this scenario? If the market was to act like this, how will we survive? Or will we be going out of business? If market acts like this, how will we survive? They can run all sorts of different simulations there like that, changing parameters and inputs and outputs and work their way like that. Then comes the presentation tools. And the process of presenting all of this to whoever you're presenting it to, be it local people or outside people, the process is called the data visualization. And one of the common data visualization tool is the dashboards. The dashboard provides easy to access information where it allows you to look for, you can drill down the things, you can click on it and then click further down and click further down. For example, you click on a department and click on an employee, and then you look at the monthly sales of an employee and weekly sales of an employee and then daily sales of an employee. You can just drill down through the process to, you can look at the critical success factors, to what are the key performance indicators, what are the status axis, what are the trend analysis, what are the exception reporting. So all of these things can be done. This is an example the author has shared with us about a dashboard. A typical dashboard will be a visual indicator of your data. Now, some workplaces have meters, especially in manufacturing. They would have meters to monitor the day-to-day activities, and these meters will notify them based on whatever their criteria is. For example, companies like Foxconn would have a very, very aggressive team looking at the production line through these kind of dashboards, especially with their digital twin technology, where every product that goes on the belt, they actually have a digital twin of that exact same product running on the digital world simultaneously. So they can identify the problems much earlier on. They don't have to wait till the product is completed and then they will do the quality assurance test on it. They can just take the item off the belt way earlier if the digital twin depicts any kind of quality problems. Okay, you know what? I will let you guys read some cases from this one. So how about we go to the beginning of the chapter and you guys read the opening case, Stitch Fix. And let me see who else came while we were in class. Okay, Angela Pocklington came. Okay. We are missing Dondre Brown, Ernesto, Brianna Johnson. We're missing Harvier, Demon Mars. We're missing Dar, Luis Vasquez. Okay. Whenever you guys are done reading the opening case of chapter 12, then I want you to start thinking about answering question number 3. So what do you guys think for question number 3? What's your thought or input on it?
I think it's mainly for brick and mortar stores because it kind of takes away the, coming into the store and then trying out and fitting rooms and stuff like that. So, for instance, like Kohl's, for instance.
Okay. So you're saying that clothing retailers will be in danger with this approach? The brick and mortar retailers in particular.
Yeah, like JCPenney, Kohl's, store in brick and mortar stores.
Yeah. Yeah. And at least for now, we still have people who prefer to go and shop personally, but the percentage is shifting towards people who prefer to buy online.
I mean, they are getting more and more money quarterly. So they started with 8 million, I think. I don't know what year, and then they just bounced up to a billion.
Yeah.
I would say that aside from just the brick and mortar, any of the clothing specialty companies would be also in danger of failing because of this company's success in their business model. Amazon started quite a while ago and was able, it's probably going to be fine, but I mean, there's not really a whole lot of other companies up until recently that allowed returning clothing items that had been bought, purchased, tried on, and worn. Aside from trying it on in the fitting room.
Okay. Okay. And that's Ethan also raised the same point that not just the brick and mortar, but online stores. Exactly. Exactly. So many years ago, in one of the malls in Michigan, I forgot the name of the mall. They created this little room that you can enter and scans you. And then when you step out of the room, it gives you a little sheet of paper in which it tells you that which stores in the mall carry your size.
That's pretty cool.
Yeah. Anyway, anybody else wants to add anything else to this? Okay, then we'll move on to chapter 13, acquiring information systems and applications. Identified, these are the 4 items that we'll be talking about in this chapter. Planning for and justifying IT applications, strategies for acquiring IT applications, traditional system development lifecycle, and alternative methods and tools for system development. And in order to accomplish this, these are the learning objectives that will be discussed within this chapter. Cost-benefit analysis, a very, very crucial thing for a lot of businesses. If I'm spending X amount of dollars, what will be the return on investment for me? And how many years will I be able to get a return on it? And I'll start making profit. So that's extremely important stuff. Then the 4 business decisions that companies must make when they acquire new apps. Enumerate the primary task and the importance of each of the 6 processes involved in the system development lifecycle and describe alternative development methods. So in the introduction, it talks about the competitive organizations move as quickly as they can to acquire new information technologies or modify existing ones when they need to improve efficiencies and gain strategic advantages. So today, acquisition goes beyond building new systems in-house, and IT resources involve far more than software and hardware. So in this chapter, you will learn about the process of acquiring the IT resources from a managerial perspective. So planning for and justifying IT applications. Just like anything, you would have to have a plan in place. So there has to be a planning done at an organizational level. Remember that in IT, the problem is defined as either it's really a problem or it's an innovative idea that will help you solve a problem, which could also mean that it is not a problem. However, it's a new idea that once you come up with that idea, you may have to create its market because there is no need for it right now, or even in future, businesses are not looking for this idea to be their need. But if it is so cool, you can actually make it their need, right? And that's exactly how a lot of these businesses function. And that's what their marketing campaigns are, that how can I make it a need? And one fine example of that is you probably, and there are cigarette companies like Marlboro. They've been selling cigarettes. Originally, when they came in the market, they were selling cigarettes only to the women. And they were not able to sell enough because back in those days, not very many women smoke cigarette. So now they're wondering, what can we do? How can we sell? We have so much stock. So somebody suggested that there's a very quick fix for this problem, if you hear me. And they're like, okay, what is it? They said, okay, all you got to do is make a cowboy rope on the box. That's it. Give it a macho look. That's all they did. They rebranded it. And they were then selling it like hotcakes. That's it. The same cigarette, just labeled differently. So that's what marketing does. So you have to have a plan in place. You have to take that plan to the steering committee, and the steering committee have to approve the plan, and they have to see the value in that plan. And then they can work with it. Even if it's a dire business need, it has to be more dire business need than any of the other needs already sitting in the pipeline. So it has to also match the organization's mission and vision statement, and it has to come in place with the strategic plan of the organization. So there has to be a planning in place. That's what basically this part mainly talks about. The mission of the information systems function, the environment, the objectives, the restrictions, the constraints, the problems, the application's portfolio, a prioritized inventory of present apps, and a detailed plan of projects to be developed or continued during current year. All of this needs to be there for them to be able to make a decision what direction to go. They have to assess the cost. As I told you, that the cost benefit analysis. Now, when we talk about cost, there are two kinds of costs. There's a fixed cost, and then there's a variable cost. The fixed cost, for example, if you are renting a facility, the rent is fixed. At least for a year, every month you got to pay X amount of dollars. But then there's a variable cost. Heating, cooling bills, they vary all year round. They're not fixed. The number of employees that you have hired, maybe you hire more employees when you're busy, and you reduce them when you're not that busy. So you have to have all these things factored into the process. And then you have to assess the benefits. Now, benefits also are of two types. tangible and intangible. The tangible benefits are those that you can quantify. They could be in the form of dollar amounts, right? But intangible, you can't really quantify them. It's just like, we just had a great year. What do you mean by have a great year? The great year, the great is intangible. We made profit. Okay, how much? Oh, we did 200% better this year. Okay, what was last year's 20,000? So 200% would be 40,000, right? But 200% sounds so good unless you take it down to the dollar value. Our customers are very happy with us. Happy is intangible. Satisfied is intangible. You can't really quantify it. So you need to look at what benefits you're drawing, because these intangible benefits can somehow contribute to your tangible benefits in the long run. That's why they're important. So you need to be able to perform your cost benefit analysis. You need to be able to look at your return on investment as to when I will be making enough. What will be my break-even analysis? When will I, what will be that point when I will at least do a break-even, that whatever money I spend, I will get at least that much money back. And then there's a net present value method to convert future values of benefits to their present value equivalent by discounting them at organizations' cost of funds. So then they can compare the present value of the future benefits with the cost required to achieve those benefits to determine whether the benefits would exceed the cost. And in business case approach, system developers write a business case to justify funding one or more specific applications or projects. The strategies for acquiring IT applications. Some corporations, as we learned earlier in this book too, that they go with off-the-shelf products. Some go with customizations, some go with in-house models. So how much does it really cost to code versus customized version versus getting a software ready to use? It all depends on the need. Where will it run? Who will, and what will happen if I have to maintain it? All of these things are part of your strategies for acquiring apps. Purchasing a pre-written application, you can go over the advantages and disadvantages of that in table 13.1, the advantages and limitations of the buy option. Every software has a life, and some companies just use those software more than they are supposed to be used for because it works. It fulfills their needs. They don't need anything more. They're happy with what they have. And software disadvantages may be that may not exactly meet the company's need, but you're living with it, right? You're just living with it. For example, if an organization, I happen to work with a client who had a division. They heavily invested in a software because that was the need of the organization. And without realizing, after they made the purchases and everything, when they had all this data collected, they wanted all this data to go to the main corporation, right? Now came a problem. There is no integration built in. The software that they purchased and the software that the company uses in the other areas, you can't integrate them. There is no support out there. And they're like stuck in silo. And now they had to literally manually transfer the data from one resource to another. So things of that nature could happen, right? Or customize a pre-written application if it lets you customize, or lease an application. Like there are cloud-based services like software as a service called SaaS, or platform as a service like PaaS, right? So you can lease the applications based on your needs, which your book also talks about it. For example, the SaaS. Moving on to open source. That's another venue. However, there is a risk factor with open source because the architecture is open. So hackers would also have access to it, and they will also exploit the architecture, and they will look for loopholes, and they will code accordingly. So, but if you're not planning on using it for external purposes, only internal purposes, they'll not be linked to any resource out there, but that's very unlikely. Most of the companies in these times are linked to the outside resources through the internet or other means. So open source software is another solution. For example, French police, many years ago, I mean, like maybe 10, 15 years ago, they decided to move away from Microsoft. And they said, we'll not be using Microsoft Office anymore. First of all, they moved away from Internet Explorer to Firefox. And then they decided that they want to stop using Microsoft Office. So where do you think they switched to?
Chrome.
No. For Microsoft Office needs. Google didn't have Google Docs back then.
Apple?
Which? What do you say? Oops.
Microsoft?
Hello, can you hear me, guys?
Yeah.
Oh,
Yeah.
my Zoom crashed. Right, we're talking about Zoom, and then my Zoom crashed.
Dang, I thought class was done an hour early.
Ah, yeah. Don't worry, it's the last one. Okay. Now that I know who is happy when the class gets done, huh? Anyway, so the French police, they turned to Open Office. I don't know if you guys have heard of them. It was a big deal back in those days where people were trying to get away from Microsoft because of its outrageous licensing cost. So for the browser, they moved to Firefox, and for the Office needs, they switched to Open Office. Outsourcing is where the corporations decide that we want to give some of our information over to somebody else to manage because they can do a better job at it. For example, some companies, like let's take an example of USPS, for example. So USPS had a contract with UPS for international deliveries. Can you imagine that? If the packet is going outside US, UPS will do it for USPS because they have a better infrastructure. So things of that nature, people have done it. So outsourcing doesn't always mean that it is going to India or it is going to China. Outsourcing could also mean that the company have decided to give this particular job over to somebody outside the company, maybe in the same city. So for example, as a gateway, we have outsourced our learning management system. To who? Who did we outsource the learning management system to?
Blackboard?
Blackboard, exactly. Who did we outsource our emails to?
Google.
Google. I exactly remember that was 14 years ago. It was the month of December. And it was the week of finals. And you know what happened? Our email server crashed.
Oh no.
Email server crashed, disk failure. They fixed it. They fixed it. And 2 days later, the same week, another disk crashed. Week of finals. This is before we were this fancy with, meets and stuff like that. This is like strictly emails. We have online students. They have no way to get in touch with instructor. You'll be like, well, yeah, you can use Blackboard, right? But the problem is Blackboard is one-way traffic. You can only send an email from Blackboard. You cannot receive it in Blackboard. So they can go to Blackboard, they can type in an email and hit submit, but where is the email going to? To the Exchange server on Gateway's on-premise computer, which is not working, by the way, right? So it was a disaster for online students. I had zero impact of it because all of my students were face-to-face, in person, 100%. But the online programs were in a lot of problem for that 1 week. Then Gateway, over the winter break, decided enough. We're switching. The switch to what you use now. And back in those good old days, students did not have Gateway emails. Only staff and faculty and administrator would, because we had limited email account. We had our own local Exchange server. And then when we switched over to, and students could use their personal emails. So those were the days when I would receive emails from some students that would directly go into spam because the email was partygirl@hotmail.com kind of emails. Of course, I'm not going to deliver it to my inbox, right? So, but then, when we moved to Gmail is when, we started giving that out to students as well. Can you imagine many years ago, Gateway actually blocked Facebook? You could not go to facebook.com from Gateway, any of the Gateway labs. And not until they had their own Facebook page, that's when they opened it. So outsourcing could also mean offshore outsourcing, or also could mean that you have simply outsourced it to somebody else. Continuous development is the biggest problem with the software, because software cost is outrageously more than a hardware cost. How much money would you spend on buying a computer? Maybe a few $100s. But the software on it, it's a continuous cost. If you are producing software for a computer like Microsoft, they have to constantly update their operating system. It's the same operating system that you're using that you've already paid the licensing fee for, and they have to constantly update it. And that goes for any other software like Chrome or any other software. Did you guys realize that Chrome has become a memory hog? Have you ever been, have you ever been to your task manager when Chrome is running?
I stopped using Chrome.
It's just unbelievable. I updated my Chrome yesterday. See, it gives me an update icon again today. And when Chrome is running, the fans are going like this. Is it a browser or is it like a server? What are you doing on my computer? So I'm kind of thinking that over the break, I will try to figure out a way where I can just leave Chrome and go someplace else. Not use Microsoft Edge. Well, I can, but here's the problem. I don't know if I showed you guys this problem. Where is it? Where's my Edge? Here's my Edge. Okay, so let's go to google.gtc.edu. This is what Edge, this is how I can view my email in Edge. Not a pretty way, right? Not very productive. Can't do much. So that's one of the reasons I did not use Edge. Other people have told me that it works perfectly fine for them, but for some reason for me it doesn't. So I'm still thinking, probably to get away from Chrome to a different browser. I
I
have,
use-
yeah, go ahead,
I use
Angela.
Firefox for most of my stuff. I mean,
Yeah,
overall, it works with most of the applications because they're competing so hard with Google. They've been trying to keep up with.
I'm thinking the same to go the Firefox route, or Firefox Edge route, and because Chrome has been giving me a lot of troubles recently. I type something in the address bar, the site never shows up. It just constantly loads, does nothing. And when I open the same site in Edge, it just goes right away. So yeah, I even uninstalled Chrome and installed it back. But yeah. Anyway, or you can employ a custom development, like we were talking to Uline many years ago, and they were in the process of buying an ERP system. Then I happened to run into their CIO back then, and he said, no, Liz, the president, she decided that they were going to build their own ERP system versus taking a customized version. So some people would go that route. Anyway, going to the system development life cycle, that how the systems are developed and maintained over the course of time. So first of all, you need to identify that there is a need. Okay. Once you identify that there is a need, there has to be some, just identification is not enough. You need to back that up with some critical information. So you need to have some investigation done. And then you need to have some systems analysis done. And then you model that. Okay, so system you analyze. Once they say, okay, looks like a good thing, then you go ahead and you start analyzing it. And then you start designing or modeling it, which would be still not programming. We have a separate modeling field in IT in particular. So for example, if I were to create a database, I will model my database by creating tables, and by linking the tables together, and I'll just create my whole entity relationship diagram. I think I probably might have shown you guys some entity relationship diagrams before. So for example, this would be an example of an entity relationship diagram model. So this would be considered as a modeling diagram, where I will list my tables and their relationship and their cardinalities and optionalities and their primary keys and foreign keys and whatnot. So then comes your actual programming and testing. And then comes, once you're done with your programming and the testing, then you go to the implementation phase, where you install the application, and then it is in the operation phase and maintenance phase till you decide to retire it. So that's pretty much the life cycle of a typical software. So there's a systems investigation phase, systems analysis phase, systems design phase. There's a system phase for programming and testing. They go side by side because there are different kinds of testing. We do walkthrough testing. There is white box testing, black box testing. QA team has their own ways of testing. Programmers do their unit testings, loop testing, conditional testing. All sorts of testings are done just to make sure the performance is there. And then the QA team is the one that is mostly responsible for doing the final testings. And then there's an implementation and operation and maintenance. So this is where you spend mostly. So if you have $100 for a software, just to help you understand, you spend $33 on these 5 steps, and you keep the other 67 for this step. That's, the operation and the maintenance cost is, of course, a lot more in long term. I will let you read through the advantages and disadvantages of system acquisition method, traditional system development lifecycle. First do that, then I'll talk about prototyping next. Okay, so what exactly is prototyping model is what we'll be looking at next. The prototyping model is where you, instead of building the entire thing from scratch, you will rather build somewhat working model, which looks like the actual model, but it's a very easily short time frame put together model. Let me give you an example. A lot of you are taking Intro to Programming and Database class. In that class, you have seen the Visual Studio interface, in which you can drag and drop and you can quickly create a form. So if somebody is asking for that, I need an application to do this, right? So you can quickly drag and drop and you can create a nice form in a very short amount of time and can show them, just to help you understand, and show them, okay, this is how your application interface will look like. And I can enter some dummy data to show you how the application will behave. But again, we need to design the database. We need to integrate a database into Visual Studio, and we have to do all of that stuff. But we have not done that stuff. But just to help you understand, this is how the end product will look like. That approach is called prototyping. Does that make sense to you guys?
Yeah.
So prototyping has advantages. It helps the user understand, oh, okay, so this is what I'm expecting, right? But the disadvantage is that since things are done so quickly, sometimes we don't put so much thought into the process, and clients sometimes build these unexpected, these unrealistic expectations that if prototype can be done in 2 days, that the software should be ready in 10 days. Those kind of, false things. So another approach that some businesses take is called JAD, Joint Application Development. And again, you'll be learning about some of these in a lot more detail in Systems Analysis and Design class, which is like a project management class in 4th semester. So the JAD approach is where you ask somebody from the client's team to sit on your project team, and they're part of your team while you are doing the whole process. Sometimes their team members, like from the client's organization, will come and have meetings with you while the product is getting developed. Or in the initial phase, you will have a proper JAD room. There's actual proper setup for a JAD room, and there are certain limitations as to who speaks and what, and mediators and proper setup and scribes. I mean, there are a lot of details in that process, but the whole idea is the client is constantly involved in the project. So if you are off track, or if you're doing something that you shouldn't be doing, could be caught right away. So that's the JAD approach, a little bit more expensive and time consuming. Then we have an integrated computer assisted software engineering. So it can produce systems with a longer effective operational life. It can produce systems that closely meet user requirements, can speed up the development process because computer assists you in the software engineering process. It's not 100% human work. It can produce excellent documentation because when you are typing stuff in your code, it can convert that commentary of your code into the actual project documentation. For example, Java allows us to write Java doc comments. And once we are done writing Java doc comments, at the end of the project development lifecycle, with a single click, it converts all those docs into a website with links. Everything is good to go in like 5 minutes. You have the whole documentation prepared. You don't have to do a thing. But disadvantages are, so some of these systems are expensive, difficult to build. Sometimes they're not accurate. And then you have to sit through and read through all that stuff and make sure that things are getting done the way they should be getting done. Then we have RAD approach, which is rapid application development approach, which can speed up the system development, where you can quickly put together something, deliver to the client, and say, okay, on your need basis, go ahead and work with this while I build the second piece and I'll add it to the first piece. Users are intensely involved from the start, though. Okay, it improves the process of rewriting the old applications. It's a good approach, but it produces functional components of final system, not the final system. You're just working on functional components. So this component works. Okay, go ahead, use it. Then you have end user development approach, which is it bypasses the information system department. And for example, nowadays, a lot of the people who are Google Doc savvy, they are using a lot of the Google services without the help of IT department. For example, they're producing Google Forms. They are working with other Google things, and they're doing it on their own sufficiently. So that's part of your end user development. It frees up IT resources. However, whatever they do, they don't understand properly what they're doing. If they have to train somebody on it, they don't have anything proper. So there are some disadvantages to that. For example, it leads to poor quality control because everybody does it their way. There is no streamlined process. There's no documentation. If that person who is so expert in it leaves, there is no knowledge base to fall back to. And then there's an object-oriented approach where you solve the business problem, how we perceive things in real life. So if I'm storing data about a customer, I will create a customer object and I will visualize the customer in this business setup. And I'll say, okay, how do you identify a customer here? And somebody will be like, okay, we identify the customer by their ID, by first name, middle initial, last name. And they must have a phone number, at least one phone number is required, and an email, which is optional. Then you start collecting all that stuff and you said, okay, I will program a special program called customers only for you. If you need to interact with the customer, you call this program. And that program can then talk to the database for you. Okay, what else do you need? I also need to talk to an employee. Okay, what makes up an employee? These fields. Okay, so I'll also create a software component called employee. And anytime you need an employee, you talk to this guy. Okay, but I need to talk to both of them. Oh, so I will gonna put together another piece of software component that will make the two talk to each other. So you're basically working in objects or object interactions. So that's another approach. Then comes system investigation phase. Excuse me. The initial stage, the very first stage in the traditional software development life cycle is where you do your investigation. Do we really need it? What are we trying to solve? Is it even a problem? How long can we do without solving the problem? You have to investigate. Once you're done with that, you have to do your feasibility analysis. Excuse me. We have technical feasibility to see how technical savvy the system is. Guys, give me 1 minute. Let me grab water. Let me grab water. It's 1 minute. Sorry about that. Okay, so technical feasibility. This is where the organizations will check to see that whatever you're building, if it is technically feasible to their current environment. Whatever you are putting, can it be installed on the hardware? Can it be installed on their existing software? Is it secure? Will it cause any problems? Things of that nature. Economic feasibility in terms of company looking at, can I afford it? And behavioral feasibility as to how will people react to it? Do I need to train? What's the training cost? Will people feel threatened? Because to them, it may be like, you're taking away my workload. So things of that nature. Systems analysis, it is a process where by system analyst examines the business problem that the organization plans to solve with an information system. The main purpose of the systems analysis stage is to put together whatever information you can get together and go to the next phase, which is the design phase. So for example, the database model that I showed you was a result of the design phase. But that design could not have happened if somebody would not have collected enough data at the systems analysis phase as to, okay, can you show me a form on which you collect customers' information? What does that form look like? Okay, what other forms do you put your customers' information in? Okay, and now you sit with all these data and you said, okay, a customer represents 15 fields from this form and 3 fields from this form. And by the way, these 15 fields on the form number 1 are not really 15 fields. They are like 21 fields because they have just one long line for address. It should be broken down into the address, the city, the state, the zip. They didn't do that. So that one long line is actually 4 fields. So things of that nature. You know, I mean, oh, they have one line for full phone number and extension. I think we should break this into phone number and extension, 2 separate fields. So an analyst is looking at things from an IT perspective, not on the paper perspective. Paper perspective is totally different. So that's another thing to keep in mind. Then comes the design phase where we start designing stuff. So for example, for you guys, have you done flowcharts in your intro to programming and database class? That's part of your design stuff. You know, I mean, like you're designing your inputs, your process, and your output. So age comes in as an input. You do something with that age and an output comes out. So that's basically what you're doing in the design phase. Not that we do flowcharts, it's just like we do other things like flowcharts. Similarly, your pseudocode is also a design tool. You guys did pseudocode too, I believe, right?
Yeah.
Yeah.
Otherwise, I'll make you do anyway in Java. I'm just kidding. So blueprint is how these components are then integrated with each other. Programming and testing. Then comes the programming. You guys already know what is programming, where you are translating what is in design phase into the actual instructions which computers can understand. And of course, based on the language of choice, you are writing it differently. So program is more or less like that's how I explained initially to people who are learning programming. It's like, consider your program like a recipe. In recipe, you have steps. Each step has to be in sync with the other steps. If any of the steps is messed up, the whole dish gets messed up. Exactly the same way, your program is like a recipe. You have a bunch of instructions. If they don't flow together, you will have a disaster, which is called an error, by the way. And those errors could fall in 3 different types. It could be a runtime error. It could be a logical error. Or it could be a syntax error. Or if you do not have any of those errors, then it will give you a perfectly fine output. So things of that nature help you understand and analyze, okay, so I have a program written. How will I know if it is functioning correctly? That's where your tests come in. You test. For example, if you're written an if condition that if the score is 90 through 100, the letter grade should be A. So as a tester, I will test it for 90. I will test it for 95. I'll test it for 100. I'll test it for 89. I'll test it for 101. And I'll write it down. First 3 tests pass. Last 2 tests fail. And they're supposed to fail because 89 should fail according to that condition. And 101 should also fail according to that condition because it has to be between 90 and 100 inclusive. So like that, as a tester, I would have to test each one of your if conditions. Each condition, even else, if, even else. To make sure that if it is meeting the lower bounds, the upper bounds, the mid bound, outside of the lower bound, outside of the upper bound. The testing is very rigorous. And this is just one code snippet testing. Now think about doing an entire unit testing, or doing a system testing, or doing a seeded testing. There are different kinds of testing models that are used by people. Then comes the implementation. The implementation is where you take it and you deploy it. Now, when you take it and deploy it, there are many ways of doing it. One of the ways is called a direct conversion. You say, okay, the old system, we will not use it anymore. Just cut off. The new system is what we'll use from now on. Good idea, but bad idea. Because sometimes things don't work on the new system and you don't have an alternate. A pilot conversion is where you introduce a new system in only part of an organization, not the entire organization. And when it's a success, then you deploy it other places. And a phased conversion is that you introduce components of new systems, such as individual modules, in stages. Each module is a sys. If it works properly, then the other modules are introduced, and slowly and gradually everything. There is another approach that some organizations take, but that approach is very expensive. Basically, you run both systems simultaneously, the new and the old. So that if you have problems, any of the problems that you are not able to figure out how to get to it on the new system, temporarily you go to the old system and fix the problem. And you make a note of it, that I had this problem and I don't know how to solve it on the new system. Either there's a lack of training, lack of documentation, or that problem was never identified in the initial stage of the development, that we also need this. Now somebody has to work and produce that unit for you to be able to do that. So until and unless corporations are fully aware that most of the things that they need for their day-to-day operations is on the new system and their employees are fully trained to use it, they usually then would not cut off the old one. But that approach is slightly expensive because simultaneously you have to maintain 2 different licenses and 2 different operational costs. Old system could also be buggy, so you need to allocate resources to fix those bugs while you are allocating resources to fix the new software bugs. So that way your work temporarily becomes double, sometimes more. So that's another thing to keep in mind. Operation and maintenance comes in after the new system is implemented. Then it's a day-to-day operation that you have to make sure that it's getting updated. Alternative methods and tools for system development. One of them is JAD. We talked about that. I don't think so we need to talk anymore about JAD, the Joint Application Development, and we also talked about RAD. Agile development. We didn't talk about agile development. Agile development is more or less like done in story forms. Like given a problem statement, you identify the problem. You basically break down the problem statement into smaller problems. That okay, this problem statement says that the company needs these 20 items. So there are 20 small problems within this one big problem. Then you prioritize those 20 items. And now you can get to the company and say, okay, these are your 20 problems. Which 5 problems do you want to be solved first? So you prioritize your list. Each prioritized item is called a story. Then you look at each story, and then you start breaking down a story into further components. And then you come up with the timeline and the resources for each story. And you build your stories, and then you deliver one pack and say, okay, the first phase is done. You're good to go. Work with it because that was your first priority while I work on your second priority. So the project manager in the Agile approach is called the Scrum Master. The product owner represents the business users and any other stakeholders in the project, and the team, which is a cross-functional group of about 7 people who perform the actual analysis, design, coding, implementation, testing, and so on. And one of the other things the Agile development approach asks you that every day the entire team has to meet in the morning, maybe for 10 minutes, where everybody will answer 3 questions, only 3 questions. Everybody will answer. What was your plan for yesterday? Okay. And did you completed it? If not, why not? Okay, the 2 questions done. The third one is, what are you planning on doing today? What's your goal for the day? So your goal for yesterday and your goal for today, and was there anything that stopped you from accomplishing your yesterday's goal? And then they start their day after that. So that's one thing that this approach has different. So we talked about end user development as well. Okay, then comes the DevOps, which is a combination of development and operations, the practice that came about quite recently in 2009. And DevOps is basically the word that people use, a combination of development and operation. It's a form of a software development that brings the developers and the users together throughout the entire process with the goal of reducing the time to deployment, increasing the usability of the finished product, and lowering the cost of new app development. But there are several factors that have increased the applications of DevOps methodology. First, organizations have less time to develop and deploy apps. There is less room for error, and the number of apps being developed is on the rise. Okay, so that's what basically have been contributing to the success of DevOps approach. Then we talked about prototyping. We talked about computer aided design, component-based development. Component-based development is also another approach in programming, where instead of recreating the whole software, you actually create the software in bits and pieces, and you plug in those pieces to complete a software. If you ever need to make a change, you take that piece out and you put in a new piece. So by piece, you mean a file or a program. And then you go to the main and you say, okay, now instead of calling so-and-so, you now call so-and-so to do the job. So if I had an algorithm written for searching the client data, and the algorithm was working at the rate of finding any client on the average in a second. Now, the requirement came in that we want the clients to be searched in less than a second. So you build another algorithm, which is more efficient than the previous one. And then you put this algorithm file in place of the other algorithm. And now you go to the main, say, okay, for search operation, don't call this algorithm, the old one, rather call this new one. So it's like a component-based programming. That's what basically this does. Different organizations have taken, or different vendors have taken different approach on it. In Java world, we call it beans-based programming. Microsoft call it component-based programming. So they have comp and comp pluses. So yeah, object-oriented development is, I already explained to you a little bit about it. You will learn a lot more about, did you guys do any object-oriented programming this semester in Intro to Programming? or no?
I feel like we learned about it in the IBMI class, but I don't think that we did it.
No. That was objects, not object-oriented programming. In the IBM concepts class, you learn that the operating system, the IBMI operating system, is an object-based operating system. That means everything on this operating system, in order to be used, has to be at an object level. That's how the operating system calls anything usable. But that's not object-oriented programming. So it's not like calling methods, because that's modularization. Object-oriented programming is where you have classes. So you talk about classes and objects and instances
Oh,
and
yeah,
getters.
we
And
learned about that.
you guys learned about that?
Yeah.
Okay. So that's the beginning of object-oriented approach. So did you find that approach to be different than your previously coding approaches in the last 13 weeks?
Yeah.
Okay, so think about it moving forward in second semester, in Java programming class, and also in the microcomputer advanced. Both of those classes are very heavily focused on object-oriented programming approaches. In fact, those classes are object-oriented programming classes. So that's where you'll be learning a lot about object-oriented approach. So in short, a class or a classification is a template, a generic idea to represent any real-world object. And any implementation of that generic idea is called an object or an instance. So for example, if I want to create a classification called car, I need to first figure out what makes up a car. So I'm going to start writing down the properties of the car. Like the car has to have a color, a make, a model, a year, price, right? All of that stuff. So that basically creates my classification or a template. The template doesn't really has any values in it. It's just a template. That template is my classification. Now I start creating cars. I said, okay, I need to create a Ford Mustang, red color, for $30,000. As soon as I load that into memory, now I have an instance of cars type. Then I say, okay, I need to have a Kia Sportage, green color, $25,000, loaded into the memory. Now I have another instance of car type. And both instances will run in memory at the same time, and they will each have their own memory. And each one of them will be called an object or an instance of the car. Means they are a particular implementation of a car. Vaguely, that's, I don't know how much of that is making sense to you guys or not, but that's what basically the model starts with. That's not the entire model, just the starting point of that model is. Does that make sense to you guys? I don't know. And I don't know how many of you are taking intro to programming and database, or are all of, is there anybody who's not taking intro to programming this semester? Oh, you're not taking, Tristan. Okay. Because you've taken it before, or Stephen? Or you'll take it in the future?
It's not needed in my program. That's why I'm not taking it.
Oh, okay. So you are not in the software developer program. That's why.
No.
Yeah. So I'm talking about the software developer students.
Oh, okay.
Yeah. So if you're a software developer student, you probably either have taken it or will take it. Okay. Or similarly, you know, the other courses I was talking about. Okay, Tristan, I see. So the other courses I was talking about, the Java and microcomputer advanced, that is also thinking from the software developers students. Anyway, moving down to containers. Containers are methods of developing applications that run independently of the base operating system of the server. So containers allow application providers to develop, test, and deploy technology that will always run in practice exactly like it does in testing. To understand containers, imagine, you know, the author is giving you an example of a vehicle is a container. You only interact with the environment inside the vehicle. Your vehicle can travel on different types of terrains, but you do the same things inside. your inside environment doesn't really changes. So application developers have always been plagued with platform challenges. Will this run on Windows? Will this run on Mac? They're like, oh, how can I make this happen? So what they did to solve the problem, they created a virtual environment within an operating system, and their stuff runs in that virtual environment. And all they did is they created different virtual environment for Mac, a different virtual environment for Windows, so that they can talk to the underlying operating system in its own language. And within that virtual environment, they just run their software, because that virtual environment understands their software. So that's like a container model. Then we have low-code development platforms, which make use of visual interfaces to develop applications rather than traditional procedural handwritten codes. So you probably have, most likely like environment like your Visual Studio, drag and drop kind of stuff. Anyway, so let me talk for the next few minutes about one thing that is your final exam and the other things that you have to work on during the week. So this week you have Unit 11. This is what we went through, chapters 12 and 13. I'll make the recording available over here. Hopefully it recorded. It also recorded everything before the Zoom crashed. But anyway, this week you have 2 quizzes, just like every week you have. Oh, there should be just, it should say 1 question, not 2 questions. I don't want to scare you guys. Just 1 question. 100 points. Okay. So 1 question for chapter 12 quiz and 1 question for chapter 13 quiz. And then for the assignments, what I did, instead of giving you guys too many problems, because you also have the final to do, I reduced for each of the assignments down to 1 question. So you have 4 of these items here. So that's 400 points here. And you have, if you go back to the units, right at the bottom, you have your final exam, which is 500 points. So 900 points in 1 week, right? Talking about pressure. So look at what I've asked you to do for the final. Read the problem. And all these items are due by next week, Thursday midnight. Does anybody has any questions about the final?
No. Seems pretty straightforward.
Yeah, it's very open-ended. As long as you cite your sources, and I mean, like, it's a very open-ended, you can pretty much talk about any ongoing topic or technology trend in any of the areas in IT, robotics, cloud computing, or even more, even beyond, like data mining, data analytics, big data, whatever, apps. It's very open-ended. So you have these 5 items to work on this week. And by the way, no pressure, right? Think about it. Yeah, you're not in his position, right? With this guy looking over. Hey, what you doing? Anyway, Bart, doesn't really matter. Does not really matter. As long as, what people have done to me, they submit their exam in a format that I don't even have access to the software. Then I have to chase them around. How do you open that? How do you open this stuff? Oh, I did it on Linux. Oh, I don't have Linux. So yeah, just don't do that to me. So as long as, it's in Word document or PDF format, we're fine. We're good to go. Yeah. I had this girl in my Gateway to Success class, and she would always turn in all her work in Google Doc format. I didn't know that Google Doc format had a file extension too, it was like G something. I'm like, what in the world is this? How am I gonna even open this on my computer? So it was a nightmare trying to download it, and then I got to put it on the Google Drive, and then I have to go to my Google Drive and open it from there. Oh, I'm like, please don't do that to me. But she did it for 7 weeks. And then she said, oh, sorry, I forgot. I'm like, okay. Anyway. So MLA format or something. See, I'm not that particular on that. So as long as it is it's not all over. It's one of the approved format. Could be APA. Doesn't matter to me. MLA or APA, doesn't matter. Okay. So what do you guys have to do for this class? Between now and next week, Thursday midnight, the assignments, the quizzes, any past due work, and the final. And everything is due by next week, Thursday midnight. Please, no extensions, because it's not in my hands to give you guys any extensions. I have to turn in the grades on Friday. So that's why you have to deliver it by Thursday midnight. So maybe you want to get started over this weekend, or something like you plan it, because I know you have other classes to do too. So plan all your classes well. And plus, since we are not meeting next week, just so that you guys know, we are not meeting next week, and that will give you that entire time to work on it too. But don't put all your stuff for the last minute that, I'll work on it on Thursday. Don't do that. Sometimes technology fails, sometimes internet outages are there, sometimes, things happen. So please don't wait till the last minute to do that stuff. Oh yeah, that excuse is out the window that my dog ate my final exam, right? Because it's all digital now. Anyway, again, I would like to thank you, all of you, for taking the class and putting up with all the punts. And here's a new one for you guys. So I will see some of you tomorrow, and I will see some of you next semester. And you guys, all the best. Thank you very much. And guys, one last thing before I take off. You guys probably would have received course evaluations in your student emails. So please fill those out. And definitely, as soon as I hear from as soon as the decision is made by the director of scheduling, we will send you guys an email hopefully next week we'll be able to resolve this issue. And thank you for your patience. Okay, Oscar, whatever you prefer. That's perfectly fine. Okay, guys, have a good night, everybody.
Have a good night.
Thank you. See you tomorrow.
See you. Take care. Okay, Tristan, I can look at yours towards the end of the class.
I have an odd question.
Yes, Angela, go ahead.
So, I mean, I'm not anticipating that I will have any missing work. However, if, say, I don't get chapter 13 done, would it be smart for me to,
You have been doing so well. If you, I mean, like that, you know, an assignment
well, would the
will
final
not
be
will
smarter
not
for me to do the
will
final? Is that like necessary?
say it again.
The final that's necessary to complete the class, correct? I guess that's what I'm getting at.
Yeah, because that's too many points. The final exam is 500 points.
Okay. I
And
just wanted to
assignment
make
is
sure
only
that-
100.
Yeah.
So I would rather, I mean, like I would, if I have to battle between, okay, should I do the final or that one assignment, I will do final.
Okay, I just
Because
wanted
that's
to make sure
worth,
that I was on the right page.
yeah, because that's
Okay.
worth a lot more points than one assignment. But do not miss on everything in unit 11, because that itself is 400 points.
Understood.
Yeah.
All right, thank you.
Okay, let me have a look at it, Tristan. Just give me one minute. That should be under unit number 8. Oh, because assignment number 8 is not available anymore. That's why. I will make it available again because it closed over the Thanksgiving break. I just closed it last week. Okay, so assignment 8 should now be available. Any other assignment besides 8? Okay, then. Tristan, since you're here, okay, did you turn in the others? You did turn in. I need to, you still have some, you have a lot of stuff to work on from the previous weeks. Are you planning on doing that, or are you leaving them the way they are? No, you need to do a lot of stuff. Okay. Can you click on your My Grades? And look at it, what you're missing there. You know what? Just 1 second. Let me put you in a breakout room, and then Devin, I'll be back with you in just a minute. Okay, Tristan, join the breakout room and I'll join you there. Oh, can you, thank you. Can you share your screen with me? And show me your my grades? Okay, cool. Um, Can you scroll down? See, you have not done anything. Assignment 2, so quiz 2, chapter 3, quiz 3, chapter 4, quiz 4, chapter 5. You have not done anything from as early as September. You just did the midterm. You did the assignment 1, quiz 1. You did the chapter 2 assignment. That was September 25th, but you didn't do anything till October 23rd. And if you scroll, and if you scroll down even further from there, you will see that chapter 6, you have not done chapter 7, 8, 9, 10. You have done nothing. So what are your plans? How are you going to do the whole semester worth of stuff in a week? Okay. Okay. Yeah, because that's very crucial for you to pass this course to be able to do. Yeah. So if 6 through all the way till the final, and probably, missing those earlier assignment, you will at least make it to the passing grade. So yeah, try to complete everything. So okay. So but assignment 8 is now up, right? So you can see it, so that should be okay. Which is part of unit number 8. And quiz for 8 is also available. So yeah. Okay. I know it'll be a little bit tough for you, but since you have not done it, so hopefully you'll be able to complete all of this stuff from 6 all the way down to the final by next week, Thursday. So that's very crucial for you to do that to pass the course. So just want to do. Okay, cool. Okay, cool. So, yeah, you can leave the room, and that's all I wanted to clear with you, so I can expect all of these things from you. Okay? No, no problem. No problem. Okay, Devin, hi. Do you have a question for me, Devin?